In this video, I would like to walk you through a review of polynomials. We'll look at long division, synthetic division, finding zeros, and graphing parabolas, as well as looking at the equation of a parabola and pulling out some information about that parabola. Here's an example. Solve this equation given that 1 is one of the zeros. Now, if I know that 1 is a zero, what I need to take from that is that I can divide, if 1 is a zero, then x minus 1 is a factor. If 1 is a zero, then I need to be able to take from that x minus 1 is a factor. So if I divide the 1 out, and I'm going to use synthetic division, so 1, negative 13, 47, negative 35, those are the coefficients of the x terms. So 1, negative 13, positive 47, negative 35. If I take those coefficients out, then the long division, we are going to drop, this is how we set it up, and then we drop down the 1 to start with. The 1 parachutes down, and then we do ma. You could think of a parachuter. He might be crying for his ma, right? His mom. But it's multiply, add, multiply, add, multiply, add. So I drop down the 1, it parachutes down, and then I'm going to multiply this 1 that dropped down times the divisor 1 is 1. If I add negative 13 plus 1, I get negative 12. And then I'm going to do it again. Multiply, ma, negative 12 times 1, negative 12. Add 47 plus negative 12 is 35. And you know, on my calculator, I could just keep a running tab here because 35 times 1 and then subtract 35 would give us the 0 remainder. Now, I shouldn't be surprised at this remainder because I knew that x minus 1 was a factor and I knew 1 was a 0. I should expect a 0 remainder. If you do the synthetic division and get anything other than a 0 remainder, then you know something was incorrect. Now, what can I do with this? I could say that this x minus 1 is one factor, and what is the other factor? If I divided x cubed minus 13x squared plus 47x minus 35 divided by x minus 1, I started with an x cubed, so I'm going to, when I divide out an x of 1 degree, the piece that's going to be left is a second degree, so we have x squared times x, and then x to the 0, which is just the constant 35. So what does this give me? It says that because 1 was a 0, this x minus 1 was a factor, and when I divided x cubed minus 13x squared plus 47x minus 35, when I divided that by the x minus 1, I get the x squared minus 12x plus 35, which is the other factor. And now you might notice that this x squared minus 12x plus 35 can be factored. So this is our f of x. If f of x is x cubed minus 13x squared plus 47x minus 35, then it could be factored x minus 1 and then x squared minus 12x plus 35. But I can factor this again. So we'll keep the x minus 1, but that green quadratic, the x squared minus 12x plus 35, could now be factored as an x minus 5, x minus 7. This is a very important step to be able to take. When I know that a 1 is a 0, I need to recognize that that means that x minus 1 is a factor, and if I factor that x minus 1 out with long division or synthetic division or any other method, I'm left with the x minus 5, x minus 7. So if I wanted to solve this equation when it's set to 0, notice that the equation is set to 0. When I set this to 0, I can now say that the three solutions are when x minus 1 is 0, x is 1. We already knew that one. If I set x minus 5 to 0 and add 5 to both sides, I'd get that x is 5. And if I set x minus 7 to 0, because I know that if I have 3 factors multiplied that equals 0, that's going to be true when any of these 3 factors are equal to 0. So I get the solutions that x could equal 1, 5, or 7. And that's the solution. Let's try another example. In number 2, we're going to pull out the vertex. So use the vertex and intercepts to sketch a graph. Give the equation of the parabola's axis of symmetry. To start with, I want to pull out the vertex. Because this is in vertex form, it's an easy x equals the opposite of 2, because remember in that form, in vertex form, it's x minus h squared minus 1. So in vertex form, the h, so the opposite of 2 is negative 2. The h is negative 2, and the k is negative 1. So the vertex is at negative 2, negative 1, this point right here. And now I can find intercept. So I could find, for example, f of 0 by replacing the x with 0. And I'd have 0 plus 2 is 2, and 2 squared is 4. 4 minus 1 is 3. So this gives me the point x equals 0, y equals 3. 0, 1, 2, 3, so that's this point. And because we have symmetry, I know that if I went 2 to the right, we go up 3, or well, actually up 4 from the vertex, so 1, 2, 3, 4, but from the axis it was up 3. If I went 2 to the left, I'd have the symmetrical point right here. And that's enough to graph this. Now, what's the axis of symmetry? The axis of symmetry is going to cut right through the vertex. It's the vertical line that cuts through the vertex. So it's this vertical line here. It's not on the graph, but it can be used to graph. And that equation, the axis of symmetry, x equals negative 2 is the axis of symmetry. And then the domain, we could have all real numbers, so from negative infinity to infinity. And the range is going to start at x equals negative 1 and include, or I'm sorry, y equals negative 1. It includes a negative 1. So we start right here and then we go up from there for the range. So we start at 1 and go up to infinity. Now the last step, of course, I can finish graphing this parabola with those 3 points. If you have any questions that you need further explanation on this, please reach out for some help, because it's important that you're able to do each of those different pieces when you go to graph that parabola and give some information about the parabola. Let's look at this next example. Write an equation in vertex form when we're given the hk. So h is 7, k is negative 1. Or if I started f of x equals a x minus h squared plus k, I can see that for this equation, I've got x minus h squared plus k. Our 7 is what goes inside the parentheses, so we have x minus 7, and our negative 1 is what goes outside the bracket, so we could get rid of that plus sign, and we have a times x minus 7 squared minus 1, but then they throw in that we've got a 3 in front of it. So the final answer would be f of x equals 3 x minus 7 squared minus 1. Number 4, use the intermediate value theorem to show that the polynomial has a real zero between x equals -2 and x equals 0. So if I were to find the value of -2, of when the value of the function when x is -2, might look like this. F of -2 equals 2 times -2 to the 4th minus 11 times -2 squared plus 6. And f of 0 would be f of 0 equals 2 times 0 to the 4th minus 11 times 0 squared plus 6. If I plug in those values, so if I plug in the -2, -2 to the 4th, well, -2 times -2 is positive 4. 4 times 4 is 16, and then 16 times 2 is 32. And then I'll say -2 squared is -2 times -2, so 4 plus 6. So if I did this 32 minus 44 plus 6, I'm going to get -6. So that's down here. When x is -2, let me write the point over here. When x is -2, y is -6. Well, let's find the point when x is 0. When x is 0, so f of 0 is going to be 2 times 0 to the 4th minus 11 times 0. So that looks like a 0 minus 0 plus 6, or positive 6. So right here. Now, if this is a polynomial, we know that there's no breaks. I don't know exactly what it does in between, but I know if there are no breaks, that it's going to start down here in the negatives, end up here in the positives. What I know for sure is that someplace along the line, we've got to cross that axis, right? So I can prove that because, let me write this point. We had x equals 0, y is 6. Because f of -2 is less than 0, and f of 0 is greater than 0, we know there's a real 0 between x equals -2 and x equals 0. So somewhere in between here, I don't know where it crosses on that axis, but I know that somewhere between the point 0.6 and the point -2, -6, that somewhere to get from here to here, we've got to cross that axis. That's the intermediate value theorem. Let's look at a function that we can pull out the vertex and use that to get some information. Determine whether the function has a minimum or maximum. Well, its lead term is positive, so I know that it's opening upward. If it's opening upward, then the vertex must be a minimum point, right? So we know it has a minimum. And then find the minimum value. The minimum value is going to occur at the vertex. So we can use this vertex formula. X equals the opposite of b over 2a. B is -9. A is +9. So here's our A, here's our B. So when I plug those in, we get the opposite of -9 all over B. Oh, I'm sorry, I reversed those, didn't I? Sorry about that. In the end, it comes out the same, but I want to make sure I do this right. The opposite of B, so B is -9, so the opposite of -9 See where I'm filling those in. All over A. So you see that this negative times negative undoes each other, so we end up with a positive, and the opposite of b over 2a ends up being 9, goes into 9 once, so we just get 1/2. So the x coordinate of the vertex is 1/2. I can take that x coordinate and find the y value. By plugging in the 1/2. So f of 1/2 will be 9 times 1/2 squared minus 9 times 1/2. That will be 9/4 minus 9/2, and that's going to give us the coordinate negative 9/4. Or you might think of it as negative 2 1/4. So our vertex is when x is 1/2, y is negative 2 and 1, oh, I wrote 2, but 2 1/4, 2 1/4. I'm going to write it negative 9/4. It's usually better to just leave our fractions improper. So the minimum value is going to be negative 9/4. And it occurs when x is 1/2. It occurs when x is 1/2. Now I can identify the domain and the range. For a polynomial, the domain is all real numbers. So for this quadratic, the domain is all real numbers. We could use any x from negative infinity to infinity. But the range has a minimum. The range starts at negative 9/4. Starts at this low point, right? But then it goes up to infinity. So the range is negative 9/4 to infinity. Let's look at an example where we can use synthetic division. We did this once. We did a synthetic division in an earlier problem, but let's try another synthetic division. If we're dividing by an x minus 2, then that gives us a 0 of x equals 2. If I set this x minus 2 equal to 0, x would equal 2. So the number I'm going to put in the bracket is the 2. And then I'm going to take these coefficients, 3, negative 4, positive 7, negative 5. I'm going to take those coefficients out. 3, negative 4, positive 7, negative 5. Draw a line, and then remember, multiply, add. Multiply, add. We keep multiplying and adding till we're done. Start with the drop down. So the 3 drops down. You can think of that 3 as skydiving down, and it calls out ma, right? Like calling for your mom because you're frightened. The 3 drops down, and then we'll multiply. 3 times 2 is 6. You know how you can do this just with a running total on your calculator. Start with the 3. 3 times 2 is 6 without deleting or erasing. Say minus 4 is 2. And then keep the 2 in there. 2 times 2 is 4. Keep the 4. 4 plus 7 is 11. 11 times 2 is 22. 22 minus 5 is 17. And so we can say that this is 3x. I'll go back in and put the x term. So I started with an x cubed, and I divided out an x. So an x cubed term and divided out a linear x. So I know that the quotient is going to be an x squared for the lead term. So 3x squared plus 2x plus 11, remainder 17. And that's our answer. Now, if you wanted to write that remainder with a plus, we could say it's 3x squared plus 2x plus 11 plus 17 over x minus 2. Either of those answers would have been sufficient or would be sufficient. Let's look at this graphing example, number 7, and this is the last one we'll do in this video. To graph this function, I'm going to start by looking at the lead term. The lead term is the positive x cubed. It's like a 1x cubed, right? So that is positive, and the degree is odd. So that behaves like a cube function where it falls to the left and rises to the right. Next, I could find the x-intercept. The x-intercept is when we let y equal 0. So if y equals 0, if this equation equals 0, let me work that out. If we have 0 equals x cubed minus 4x squared minus x plus 4. Do you see that what I could do is factor this to solve it? So I'm going to factor out an x squared. So factor by grouping. And I'd have x minus 4. And then I could factor out a negative 1, x minus 4. So it gives us x squared minus 1 and x minus 4. But now I could continue to factor this x squared minus 1 is x plus 1, x minus 1, and then x minus 4. So those are our factors. Find the x-intercepts. If I solved each of these, if I set each of these factors to 0 and solved, I'd get that x equals negative 1, positive 1, or positive 4. X equals negative 1, x equals positive 1, x equals positive 4. And then to find the y-intercept, that's the easy one. That's where I simply plug in 0 for x. I'm going to use the empty parentheses. So cubed, x cubed minus 4x squared minus x plus 4. So if I put in a 0 to find the y-intercept, that means x is 0. So 0 cubed minus 4 times 0 minus 0 plus 4, I get the intercept 4. If I graphed these points, x equals negative 1, x equals 1, and x equals 4. There's our x-intercepts. And then now we have our y-intercept. Y equals 4. And I know that this graph starts up, oh, sorry. That's not how we determined it, right? We said it starts down here because it's rising on the left. Going, or from the left to right, we're going up. So I know that the end behavior looks like the arrow down and the arrow up. Then I can graph, I can fill in the rest of this, at least with a rough idea, right? That we'd go something like that. And that would actually be sufficient. Let's look at another problem, and this next problem does the same thing, but it's just a slightly different example. So I'm going to pause the video now, and we'll start part 2 video with this next example. If you do have any questions about these examples or need further explanation, I do hope that you'll reach out to me to let me know.